You know that feeling when your computer starts making that weird rhythmic clicking
Oh,
sound?
yeah, that awful clicking.
Right, and the screen just freezes for like a fraction of a second too long, and you instantly get that pit in your stomach.
Because you realize you haven't backed up your hard drive in, what, months?
Yeah.
Maybe years?
Exactly. All your photos, your documents. I mean, your entire digital life is just sitting on one fragile spinning disk that could literally crash at any second.
It's a really profound feeling of vulnerability, you know?
Yeah.
You're basically one hardware failure away from a total wipe.
And it's usually the exact moment you scramble to buy an external drive. Well, welcome to today's deep dive. We are looking at a stack of incredibly intense notes from Ziko's space stories.
Yeah, and these notes center on a pretty chilling warning recently issued by Elon Musk.
Chilling is right. He argues that human civilization is currently acting exactly like that unbacked up hard drive.
Right.
The warning is stark. He says either we become a multi-planetary species within this century or, well, humanity faces inevitable extinction. It's a lot to process.
It is. I mean, an asteroid, a pandemic, a nuclear event. If Earth goes down, the human experiment just ends.
Which completely reframes the lens through which we view space exploration. I mean, for everyone listening. This isn't about the romance of discovery anymore.
No.
It is about establishing a literal physical redundancy for the human race, a backup drive.
Exactly. So the mission of this deep dive is to explore the extreme engineering and, frankly, the terrifying biology required to actually build that planetary backup on Mars.
Yeah, it's not a simple copy-paste job.
Far from it. We are going to unpack the raw mechanics of the rockets being built to get us there and the brutal physiological toll the journey will exact on the human body.
And we also have to look at the zero-margin reality of surviving inside a pressurized Martian dome. Plus, the wild physics of terraforming a dead world.
Right.
But we really need to strip away the glossy, starry-eyed science fiction of this whole endeavor.
Yeah, because it's not all just floating in zero gravity looking at the stars. Exactly. Because the physics and biology detailed in these notes make it explicitly clear that planetary colonization is mathematically unforgiving. It's highly toxic and fundamentally hostile to human life.
Okay, let's unpack this. If we are backing up humanity, the immediate bottleneck is the transfer cable, right?
That's a good way to put it.
Like, how do we actually move thousands of tons of infrastructure and human biology to another planet?
Well, the answer to the notes is the SpaceX Starship.
Right, this thing is a beast. It's a 400-foot-tall vehicle pulling over 17 million pounds of thrust.
It's the most powerful rocket ever built.
But the detail that really stands out isn't even the size. It's the fact that it is constructed entirely out of stainless steel.
Yeah, which immediately seems counterintuitive.
Totally. I mean, why build a spacecraft out of something so heavy when aerospace engineering is usually obsessed with, like, ultralight carbon fiber or aluminum?
Well, it comes down to thermodynamics and reusability. Stainless steel has an exceptionally high melting point. When a spacecraft re-enters Earth's atmosphere at orbital velocities, the friction compresses the air in front of the ship.
Right, it creates that massive heat shield effect.
Exactly. It generates plasma that reaches thousands of degrees. Traditional spacecraft, like this space shuttle, had to use incredibly fragile, lightweight ceramic heat tiles to survive that.
And those tiles had to be meticulously inspected and, like, replaced after every single flight, which took months.
Precisely. Steel, however, can absorb and dissipate an immense amount of that thermal shock without compromising its structural integrity.
Wow.
It allows the vehicle to survive atmospheric re-entry, land, be refueled, and just launch again with minimal refurbishment.
So it behaves less like a delicate experimental spacecraft
Yeah.
and more like a commercial airliner.
If we connect this to the bigger picture, this is why Starship matters. Reusability fundamentally rewrites the economics of space travel.
I mean, it makes sense. Building a multi-billion-dollar rocket and throwing it into the ocean after one use is like throwing away a 747 after a single flight from New York to London.
The ticket prices would be astronomical.
Exactly. You'd be paying millions for a coach seat. But Starship's reusability is projected to drop the cost of launching cargo by over 99%.
Which shifts Mars from a one-off science experiment to an economically viable mass-scale colonization effort.
But there is a logistical detail in these plans that just feels completely unhinged to me.
Oh, the fleet size.
Yes, the vision isn't just to build a few of these. Musk proposes building a fleet of 1,000 starships to launch thousands of people simultaneously.
It's a massive armada.
Wait, logically, how do you even fuel an armada of 400-foot rockets without risking a catastrophic cascading explosion on the launch pad?
Well, you don't fuel them all from Mars on the launch pad.
Oh, you don't?
No, that is where orbital mechanics come into play. A Starship uses almost all of its cryogenic liquid methane and liquid oxygen just to escape Earth's gravity well.
Just to get into orbit.
Exactly. So the strategy is staging. You launch the passenger ships into low Earth orbit, then you launch separate tanker ships to rendezvous with them in the vacuum of space.
Wait, so they are refueling in space?
Yes, transferring thousands of tons of super-chilled propellant in zero gravity.
That sounds incredibly dangerous.
It's a huge engineering challenge. Only once the entire armada is fully fueled in orbit do they fire their engines simultaneously to break away toward Mars.
Okay, so the orbital logistics are technically feasible, but this exposes a massive friction point.
The human element.
Exactly. You've built the indestructible steel transport, but you are putting incredibly fragile human biology inside it.
We are terrestrial organisms perfectly calibrated for Earth's gravity and magnetic field.
Right. So sealing humans in a steel tube for a 6 to 9 month transit sounds like a physiological nightmare. I want you, the listener, to just imagine that psychological horror for a second.
It is the ultimate biological bottleneck. We are forcing a terrestrial animal into a frictionless radiation chamber.
Let's talk about that radiation, because on Earth, we don't even think about cosmic rays.
Because we don't have to. Earth's spinning molten iron core generates a massive magnetic shield.
The magnetosphere.
Exactly. It constantly deflects high-energy subatomic particles and solar flares shooting through the solar system.
But the moment a starship leaves Earth's orbit, that invisible shield is just gone.
Yes. The passengers are continuously bombarded by cosmic radiation moving near the speed of light.
Which literally tears through DNA strands.
It does. It causes microscopic cellular damage, drastically increasing the risk of aggressive cancers, acute radiation sickness, and even cognitive degradation.
Wait, cognitive degradation, like brain damage?
Yes, as these heavy particles pass directly through brain tissue. And shielding a ship entirely would require walls of lead so heavy the rocket could never lift off.
So you just have to absorb it. And while your DNA is being shredded, your skeleton is actively dissolving. You are in zero gravity for up to 9 months.
And the human skeleton is not a static structure. It is living, active tissue. On Earth, the mechanical stress of walking and carrying your own weight signals your osteoblasts, the bone-building cells, to continuously reinforce your skeleton.
But in space, there's no weight.
Right. In microgravity, that mechanical stress drops to zero. Your body's internal logic determines that a dense, heavy skeleton is a waste of metabolic energy.
Because you're just floating. You literally don't need legs to hold you up.
Exactly. So the cells that resorb old bone begin to vastly outpace the cells building new bone. Your bone density plummets.
That is terrifying.
And your cardiovascular system also weakens. Because your heart no longer has to pump blood vertically against gravity, the heart muscle physically shrinks.
Seriously, picture yourself inside that cabin. You can't open a window, you can't step outside to stretch your legs, and for 3 seasons of a year, your body is actively dismantling its own architecture.
It's a grueling test of endurance.
And if something goes wrong, say a critical life support valve fails on month 3, you can't just turn the ship around.
Orbital mechanics strictly forbid it.
Really? Why can't you just fire the engines and go back?
Space travel is governed by delta V, or the change in velocity. Once you fire your engines to leave Earth orbit, you are traveling at tens of thousands of miles per hour.
Right.
Because space is a frictionless vacuum, there is no air resistance to slow you down. To hit the brakes and reverse your momentum back to Earth would require an astronomical amount of fuel that you simply do not have on board.
So you are entirely locked into a ballistic trajectory. There's literally no escape hatch.
You are committed to the math, which is why the theoretical physicist Michio Kaku points out a very sobering reality in the notes.
What does he say?
He says the first wave of pioneers has to accept a very high probability that they will not survive the transit. There is a very real chance of death just to make the trip.
Just getting there is a filter.
It is an extreme filter. You have to synthesize the conflict between our technological ambition and our evolutionary reality. The void of space is actively hostile to our existence at every single biological level.
But let's assume you beat the odds, right? You endure the radiation, you maintain enough muscle mass to actually stand up in Mars's partial gravity.
You land.
You land. But stepping off that rocket is not a victory lap. The destination is arguably just as hostile as the vacuum of space.
Oh, in many ways, the arrival marks the beginning of an infinitely more complex survival scenario.
Because Mars is a dead world. It has a trace atmosphere that is 95% carbon dioxide, sub-zero temperatures.
And the atmospheric pressure is incredibly low.
Right. The pressure is so low that if you stepped outside without a spacesuit, the water in your lungs and saliva would literally boil at body temperature.
In a brutal environment.
Here's where it gets really interesting, though. You aren't moving to a new frontier to build a cabin in the woods.
No, not at all.
You are permanently moving into a high-stakes, pressurized nuclear submarine parked in toxic dirt, knowing you can never leave it without heavy armor.
A submarine is the perfect mechanical equivalent because survival requires an absolute zero margin for error, closed-loop ecology.
How close are we talking? Like sharing recycled air?
At the molecular level, every exhalation of breath, every drop of sweat, every ounce of wastewater must be captured by atmospheric dehumidifiers.
Oh, wow.
It all has to be chemically filtered and treated to become drinking water again. You cannot simply vent waste into the atmosphere and draw in fresh air.
So you were drinking yesterday's sweat, and supplemental water has to be mined, right? But you can't just melt Martian ice and drink it?
No, absolutely not. The Martian regolith is saturated with perchlorates.
Perchlorates, what are those?
They are highly toxic chemical salts that severely disrupt the human thyroid gland and central nervous system.
So the dirt is basically poison.
Yes. Any ice mine from the subsurface has to be extensively heated and chemically purified before it can even enter the dome's water cycle.
And I imagine the same strict closed loop applies to food. No foraging, no hunting.
None. Everything has to be grown in advanced hydroponic labs under artificial UV lighting, utilizing every ounce of organic compost the colony produces.
But this exposes a huge logical flaw in the entire backup drive premise, doesn't it?
What do you mean?
Well, a backup drive is supposed to be secure. If humanity is hiding in pressurized glass domes, completely dependent on mechanical air scrubbers and water purifiers, I mean, a single micrometeorite strike or a cascading electrical failure in the hydroponics bay wipes out the entire colony in hours.
That is a very valid point.
We haven't backed up humanity. We've just put a few people in a very fragile, high-maintenance jar.
Which is the exact hurdle that planetary scientists acknowledge. A dome is a temporary staging ground. It is an incubator.
Okay, so what's the permanent solution?
The only way to create a true permanent backup for human civilization is to fundamentally change the host environment to match human biology, rather than permanently isolating biology from the environment.
Terraforming. This is the section of the notes that reads like a comic book, but it's entirely grounded in hardcore thermodynamics.
It's an incredible concept.
The ultimate goal is to give Mars a thick, breathable atmosphere, flowing liquid water, and a green landscape. But the proposed catalyst to kickstart this process? Well, to melt the Martian ice caps. Proposals include using massive orbital solar mirrors to focus sunlight, or literally dropping thermonuclear explosions over the poles.
Yeah, that's Elon Musk's more extreme proposal.
Wait, bombing a planet to save it? That sounds completely counterintuitive. It sounds exactly like a supervillain's plot. How does detonating thermonuclear weapons over an ice cap create a breathable atmosphere?
I know it sounds destructive, but the goal isn't kinetic damage. It is rapid, massive thermal energy release.
Okay, walk me through the physics.
Mars has millions of tons of carbon dioxide locked up as dry ice at its northern and southern poles. By detonating high-yield thermal devices in the atmosphere above the poles, or focusing giant mirrors, you rapidly vaporize that frozen CO2.
So you are injecting millions of tons of gas directly into the thin atmosphere.
Exactly. You are deliberately triggering a runaway greenhouse effect.
Oh, wow.
What's fascinating here is that you're basically putting a giant planetary blanket over a frozen engine to trap its own exhaust heat.
Because the CO2 absorbs the sun's infrared radiation, which warms the planet.
And that warming melts more ice, releasing more CO2, creating a thermodynamic feedback loop.
It feeds itself.
Exactly. As the atmospheric pressure increases, liquid water can finally flow on the surface without instantly boiling away.
It's brilliantly ironic, isn't it? On Earth, we are spending billions of dollars in completely restructuring our global economy to halt the greenhouse effect because it is destabilizing our climate.
It's our biggest threat here.
Right. But on Mars, we want to intentionally weaponize that exact same physics to spark a global climate from scratch.
It is applied physics on a planetary scale. And once you have a thicker atmosphere and liquid water, you introduce genetically modified cyanobacteria in extremophile plants.
So you start planting things.
Yes. These organisms begin the centuries-long process of photosynthesis, breathing in the CO2 we just released, and slowly exhaling oxygen.
But the key variable here is time. This thermodynamic cascade wouldn't happen overnight.
Oh, not at all. We are talking about a time frame of several centuries, perhaps even a millennium.
1,000 years.
Easily. The people who construct the orbital mirrors or detonate the thermal charges will never breathe the air they are creating. They will live, work, and die entirely inside the pressurized domes.
It's an immense multi-generational commitment. It's like building a grand cathedral, knowing you will only ever see the foundation.
It requires a level of long-term, species-level coordination that we have rarely, if ever, demonstrated on Earth. It is the ultimate expression of the drive to ensure the survival of human consciousness.
So let's pull all of this together. We started with Musk's chilling warning that Earth is a single point of failure, an unbacked up hard drive.
A very fragile one.
Right. And we've seen the raw brute force engineering of the Starship trying to answer that call, leveraging stainless steel and orbital refueling to make mass transit mathematically viable.
But we also confronted the severe biological reality. The deep space radiation, the zero-gravity bone resorption, and the unforgiving physics of orbital mechanics that make turning back impossible.
And the harsh truth that arriving simply means trading the vacuum of space for a toxic, freezing desert. Living in a pressurized, zero-margin, closed-loop dome, drinking recycled sweat, and working for generations to slowly weaponize a greenhouse effect until the planet finally thaws.
It really shifts the conversation from a technological challenge to a deeply psychological one.
It really does, which leaves you, the listener, with a massive question to mull over. Knowing everything we've just unpacked from these notes, knowing that the transit will physically break your body down.
Assuming you survive the trip.
Right. Knowing you will be trapped in a glass bubble, hyper-aware that a single cracked seal means instant suffocation. Knowing you are laying the groundwork for a green planet you will never live to see, would you go?
That is the ultimate question.
Imagine yourself for a moment. You are standing on the launch pad in Texas. You look up at that 400-foot wall of stainless steel. You hear the Raptor engines starting to prime.
The ground is shaking.
Yeah. And as you strap into your seat, you look out the window at the blue sky of Earth, knowing it is an absolute certainty it's the last time you will ever see it. Do you push the button?
It's a heavy choice.
And consider this something the sources hint at, but we haven't even touched on yet. What happens to the minds of the people born inside those domes?
The second and third generation.
Exactly. If you are a third-generation colonist who has never felt wind, never seen an open sky, never swam in an ocean, and never known Earth as anything more than a tiny pale blue dot in the blackness of a telescope, do you even consider yourself part of the same species anymore? Or does the backup drive inevitably overwrite the original programming?
That is a profound thought.
Something to think about.